Day 5 notes, Intro to Rational Functions. Warm up, which is review. Definition of a function. And we learned this in first semester, so hopefully you remember, for every input, there is only one or exactly one output. Another way to look at that is for every input x, there is only one output, which is the y value. In first semester, we also looked at several different types of functions, several different types of parent functions, and one of them that we studied was a quadratic, and we also looked at this extensively second semester. What shape is the function y equals x squared, your quadratic? And hopefully you remember that that's a parabola or a U-shaped graph. How is the function x plus 7 squared plus 5 shifted from the parent function y equals x squared? So again, from first semester, hopefully you remember that the plus 7 in parentheses is the opposite of what you think. And so plus, you would think to the right, but this is really to the left. So this is left 7. And then the plus 5 on the outside of the parentheses is up 5. How is the function x minus 4.5 squared minus 32 shifted from, again, the parent function y equals x squared? And if we have, again, in parentheses, it's the opposite of what you think, so this would be to the right, 4.5 units. And the minus 32 would be down 32 units. Also in first semester, we reviewed equations of horizontal and vertical lines, and we're going to need that in this second half of chapter 9. So if we take a look at our first equation, if I ask you what's the y-intercept here, you would say, oh, the y-intercept is 2. So we could say y equals 2, and then the slope is rise over run. So if I pick any 2 points, how many up do we go? We go up 0 over 2, and 0 divided by 2 is 0. So the slope is 0, and so if we wrote plus 0x, that's the same as just writing plus 0. So we don't even need to write it. So the equation for this horizontal line is y equals 2. Let's take a look at our next horizontal line right here. Again, I might ask you, what is the y-intercept? And you would say that that's y equals negative 3. Again, if it's a flat line, the slope is 0 because we go up 0 and we can go over however many we pick. So 0 over 3 is still 0. And if we write plus 0x, it's the same as just writing y equals negative 3. Okay, let's take a look at our vertical lines here. And this has no y-intercept for this line, but I might ask you, what are all the x values on this line? And it doesn't matter what the y values are. Everywhere on this line, the x value is negative 2. So we say this line is x equals negative 2. And for this last vertical line, again, it doesn't have a y-intercept, but I might ask you, what is the x value anywhere on this line? It doesn't matter what the y value is. The x value is 4. So we say x equals 4. So when writing equations of these horizontal and vertical lines, it's the opposite of what you think. If it's a horizontal line, we usually think the x-axis is horizontal, and it is. But if the line is horizontal, it's y equals. So this is y equals 2, y equals negative 3. If it's a vertical, again, we usually think the y-axis, but here all the x values are negative 2, so x equals negative 2. And in our last vertical line here, all the x values on this line are 4. Doesn't matter what the y value is. So we have x equals 4. And so we're going to be using these equations of lines in this next part of the chapter quite a bit. And we're also going to be looking at review, which is how do things shift and how does that affect the graph. All right, so let's get to the new stuff today. Intro to rational functions. You should feel hopefully comfortable now simplifying, multiplying, dividing, adding, and subtracting rational expressions and rational functions. But now we're going to look at graphs of rational functions and explore more. So just to review, a rational function is a function that is the ratio of 2 polynomials. It is rational because one is divided by the other like a ratio. Note, the polynomial we divide cannot be 0. You can't divide by 0, so the bottom can't be 0. So our goal today is to explore rational functions, and we are going to look at something called an asymptote. So step 1, can you graph the parent function y over x by filling in the table below and graphing the points? What happens when x equals 0? Okay, so let's graph this. I've made a table and picked the x value, so all that's left is to plug it into your function and then get the y value. So the first one, we'd have y equals 1 over negative 4, which is negative 0.25. So let's write that right here, negative 0.25. And our second table value, it's 1 over negative 3, which is negative 0.3 repeating. In our next value on our table, we have 1 over negative 2, which is negative 0.5. Our next one is 1 divided by negative 1, which is negative 1. 1 divided by 0 is undefined. Again, we've talked about this in class. At least I think I did first semester, where you can't divide by 1 because the number is just so big, it's undefined. So I'll write that there. 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 3 is 0.3 repeating. And 1 divided by 4 is 0.25. So all I did is pick some points, and we're going to graph these and see what this looks like. All right, so now on our little coordinate plane here, I'm going to graph negative 4, negative 0.25, negative 4, negative 0.3, negative 2, negative half, negative 1, negative or positive 1, and then we have this undefined, and then we have 1, 1, 2.5, 3, 1/3, and then we have 4, 1/4. Oh, and I graphed these wrong, didn't I? Yes, I did. So I'm going to change these. These were negative, and I put them in the positive. So let's redo that. Okay, so negative 4, negative 0.25 is here. Oops. Negative 3, negative 1/3 is here. Negative 2, negative 1/2 is here. And negative 1, negative 1 is here. And then if we are to graph it, it would look something like this. Okay. So this graph approaches two lines, but it doesn't touch them. And that line, that invisible boundary line that it does not cross, is called an asymptote. Oops, I spelled it wrong. All right, so asymptote. And again, an asymptote is kind of like an invisible fence. So like it's like your dog would approach the fence, but it's not going to cross it because it doesn't want to get shocked. So that's an asymptote. And it says, what is the equation of the vertical asymptote? The vertical's up and down. So here's our vertical asymptote. And that is at x equals 0. And our horizontal asymptote, horizon, so think flat, is y equals 0. And again, you can see they're like invisible fencing. So the purple line might be the path of like your dog. It approaches the fence, but it's not going to cross it because it doesn't want to get shocked. So there's like the invisible boundary lines right there. Okay, let's talk about domain and range of this. Okay, so we did graph this function. This is the function y equals 1 over x. Here's what the parent function looks like. Different than functions that we've looked at before, like our absolute value and our quadratics and so on. So here is 1 over x, a rational function. This is what it looks like. Has asymptotes, invisible boundary lines, and domain and range. Let's talk about that. So domain is all possible x values. And if you take a look, this graph has all possible x values except for right here. At x equals 0, notice our graph goes all the way to the left, all the way to the right, but it does not cross at x equals 0. And so we say here that the domain is x is everything except 0. X can't be 0. And the range is all possible y values. And if we look at what y values are possible, how far up and how far down, we can see that it goes this way, but then it can't cross at 0, and then there's values down here as well. And so we say that, okay, y can be everything except 0. So those are, if you notice the domain and the range, all possible x and y values, are everything except the asymptotes. Okay, so again, the asymptotes can exist, so the domain and range is everywhere except where those invisible fences are. All right, where do you see real-world examples of rational functions? Here's an example right here, the forgetting curve. If you want to read through this, there was a psychologist in 1885 that tested his memory by learning lists of nonsense syllables such as wid and diff, and attempted to recall the syllables at particular points in time. And you can see that the longer time went on, the lower the retention, but his retention was never negative. And so there's these asymptotes that existed because time can't be negative and your memory can't be negative. And so there's an example of a rational function. And so today we are going to explore rational functions, this new shape that we have right here. And we are going to explore how we can use what we've learned previously and apply it to this new function. Okay, so what might your assignment look like today? We're just going to do a few examples, and then you'll try that in the daily practice. All right, so here's the first type of problem I will give you. Write the equation of each graph transformation of the parent function y equals 1 over x, and give the vertical and horizontal asymptotes, and also the equation. All right, so again, here's our mother function, our parent function, y equals 1 over x. But what if you translated that graph 7 units to the left? So now we're going to write y equals 1 over, and left and right is inside the parentheses, or in this case, beneath the fraction. So you don't really need the parentheses. I like to put them in though. And it's 7 units to the left, so x plus 7. So that would show us, hey, take 1 over x and shift it 7 units to the left. All right, now notice our asymptotes were at x equals 0 and y equals 0. So if we shift it 7 units to the left, it changes our vertical asymptote. Okay, so let's reflect that in the answer. So 7 units to the left, the vertical asymptote is x equals -7. We didn't shift it up and down, so the horizontal asymptote is still sitting there at y equals 0 because we only shifted it to the left. Okay, so let's write y equals 0. All right, let's do the second one. Translate the graph 10 units down and 4 units to the right. Okay, so I'm trying to use color here. Okay, so 10 units down and 4 units to the right. Okay, so down is outside the parentheses, x minus 10, and then to the right would be -4. Okay, so let's start here. 4 units to the right. It shifts everything right 4, including the vertical asymptote. So we would say x equals 4 is the new vertical asymptote. And the horizontal asymptote, we're going up and down here. We're going to go down 10, and it was at 0 here. So now shift it down 10, and the horizontal asymptote will be y equals -10. Okay, so again, here's the equation. The vertical asymptote is the opposite of what's in the parentheses. The horizontal asymptote is what you see on the outside of the parentheses. Okay, next type of problem. It says, as the rational function y equals 1 over x is translated, asymptotes are translated also. Write an equation for the translations described. All right, so there's a horizontal asymptote at y equals 3. So this went up 3, and a vertical asymptote at 0, so it did not go left or right. Okay, so we have y equals 1 over x, and it went up 3, so plus 3 is on the outside. Let's try the next one. It has a horizontal asymptote at y equals 11, so this is up 11, and a vertical asymptote at -9, which means it moved left 9. Let's write the shifted function, y equals 1 over parentheses. Left is plus, so x plus 9. And up is also plus, so on the outside of the parentheses, plus 11. So there's the equation of that shifted function. Okay, let's talk about 2 more types of problems, and then you'll be able to practice this. What are the equations of the asymptotes for each function? All right, so let's just talk about the shifts here. And so this one goes to the right 9. So the horizontal asymptote did not change. Horizontal is y equals, and it didn't change. But the vertical asymptote went right 9, so x equals 9. And then the domain is x value, so x is everything but the vertical asymptote. And the range is everything but the horizontal asymptote. So we say x can't be 9 and y can't be 0 because there's those invisible fences there. All right, let's talk about the next one. This is 2 shifts. So this is plus 5, which is left 5, and minus 3 is down 3. All right, so the horizontal asymptote, we're looking at what goes up and down. So this is down 3, so y equals -3. The horizontal asymptote goes left and right, or the vertical asymptote goes left and right, and is left 5, so -5. The domain is everything but the vertical asymptote, and the range is everything but the horizontal asymptote. I want to show you what this looks like. So, and you can do this too. Remember, if you have that Desmos app on your device, so I'm just going to go to Desmos or on your computer. All right, I'm going to type this in so we can see this shift of left 5 down 3. So we have 7 over x plus 5 and then minus 3. So the 7 deals with something that we haven't looked at yet, but we do see our asymptotes. I should type in the parent function too, 1 over x. Okay, so the blue is your parent function. You can see the asymptotes at y equals 0 and x equals 0. But then in the red, it's shifted left 3. So here's your new asymptote. Not left 3, I'm sorry, left 5 and down 3. So you can graph these and see what that looks like if you are visual like that. Okay. And then we have this negative 3. Again, that's not dealing with what we're looking at today. We're simply looking at the left and right shift and the up and down shift. Okay, so the horizontal asymptote deals with going up and down. So this goes up 18, so the asymptote also shifts up 18. And this also goes to the left 1, so the vertical asymptote will shift left 1 as well, so x equals negative 1. The domain is everything except the vertical asymptote, and the range is everything except the horizontal asymptote. Okay, so I'll ask you questions that deal with looking at the equation and telling me the asymptotes in domain and range. And then lastly, can you match the equation of the graph? Draw arrows matching them. Okay, so let's take a look at this function right here. Again, we're not dealing with the negative 3, but we are looking at the bottom of the fraction. And this graph moved right 5. This graph, again, we're not looking at the 11. And this one has no vertical or horizontal shift, so it looks a lot like the mother function. And this one has 2 shifts. It goes right 3 and down 1. Okay, so I'm going to start with the one that looks like our mother function, no shift at all, and that would most resemble this graph right here. All right, how about our graph that goes right 5, and they both go to the right, but which one goes right 5? And it's this one right here, so that matches over here, and that leaves our, so let me make this, okay, so this one goes way over here, this one's A, and this one is B, and so then C would be this one here, right 3 and down 1. You can see those asymptotes, right 3, down 1, so this is C right here. Okay, so day 5, daily practice. You can take a look at the notes. It will be similar types of problems, testing you on patterns that we've looked at before, just with different functions. And now you're going to apply to rational functions.